Hello and welcome to a video on lesson 3.1. Happy return back from fall break. I hope it was wonderful. And let's get started in module 3. So module 2 is all about quadratics. Module 3 is all about cubics. And this is the new part of algebra 2 that you've never seen before, which is kind of exciting. So we've got two goals today. We're going to identify a degree and a leading coefficient of a polynomial, and then we're going to determine key features of cubic functions. So first off, our first vocab word is a polynomial function. It's a function where all the exponents are positive whole numbers. So take a look at this table, polynomial versus not polynomial. Exponents. For linear, the exponent is secretly a 1 up here. 1 is a positive whole number. For a quadratic, 2 is a positive whole number. This is called a quartic, fun fact. So 4, positive whole number. Again, squared, positive whole number. So all of the following are polynomials. These are not polynomials. If you have an x in the exponent, if you have any square roots, if you have any x in the denominators, or if you have absolute value functions, that would not be a polynomial. So we are just going to focus on cubics today. So a polynomial is said to be in standard form when it is written in order from the biggest exponent to the smallest exponent. So in this following polynomial, I've got 4x to the fourth minus 3x to the fifth plus 7 minus 1/2 x squared. And I need to put it in order or in standard form. So you're going to look at the exponent. The highest exponent is a 5. So that would be a negative 3x to the fifth. And that's going to go first. All based on your highest exponent. The next highest exponent, if we look, would be this 4x to the fourth. 4x to the fourth is positive, so I'm going to put plus 4x to the fourth. And if you want to underline it, hey, we did that. So I've got those two knocked out. Out of these two, x squared would be your next variable. So that would be a negative 1/2 x squared. So the sign follows your term. And then last but not least, that 7, positive 7, would be the last term. And so that is how you put something in standard form. Look for the highest exponent all the way down to no exponents at all. Now, once you put something in order or in standard form, you can find the leading coefficient. So the leading coefficient is going to be the coefficient or number on the first term. And so I've put this in order. My leading coefficient, the number in front, would be a negative 3. Okay? So coefficient, just a number. The degree, this keeps popping up, is going to refer to the exponent. And so it's your greatest exponent. So again, my greatest exponent was a 5. So our degree of this polynomial would be a 5. So that's kind of a few new vocabulary words for us. Degree is an exponent. Leading coefficient is the number in front when you put it in order, aka standard form. Okay, moving on. So this module, again, we talked about is all about cubics. So let's compare cubics to quadratics. So I know y equals x squared makes a u on the graph. So let's sketch a nice little u. And then we're going to talk about our lovely favorite thing, end behavior. So I put this positive infinity on the right, negative infinity on the left to kind of help us remember where positive and negative infinity is. Same thing with your y-axis. Positive infinity is at the top, negative infinity is at the bottom. So let's talk about end behavior again. We know it starts with as x goes to. We typically do negative first. I'm going to try positive. Switch it up today. So remember, as x goes to negative infinity, that's a fancy way of saying the right. So on the right side, what is my arrow doing? My arrow is pointing up. So my y values, or f of x values, are going to positive infinity. So last module, we said y. Let's be a little bit more fancy this module. We're going to say f of x. And we know we've got two answers for our end behavior. You've checked the right side of the graph, positive infinity. we have to check the left side of the graph, negative infinity. So your left arrow is also pointing up, and so I know my y's are also going to positive infinity, which again, instead of y for this module, we're going to say f of x to be fancy. Okay? So that was last module, quadratics and behavior. What does a cubic look like? Let's graph it. So in my calculator, if I go x and then raise it to the third power, that is a cubic. If I hit graph, it does this nice little snaky thing. So that is what a cubic looks like. It snakes up really high. So let's draw that on our paper. So again, you've got your positive infinity to the right, positive infinity to the top, negative infinity to the left, and negative infinity to the right. So let's talk about this end behavior. It's going to be a little bit different. Our f of x values were always the same for a quadratic because our arrows were pointing the same direction. For cubics, they are not going to be the same answer because they're pointing different directions. So let's start off with as x goes to positive infinity, which is a fancy way of saying the right. So what is my right arrow doing? My right arrow is pointing up. Therefore, my y values, or my f of x values, are going to go to a positive infinity. Now let's check the other one. So let's try as x goes to negative infinity. So again, those will always be in your problem. Negative infinity, x is the same thing as saying your left arrow. So what is my left arrow doing? My left arrow is pointing down. Therefore, my f of x values, or my y values, will go to negative infinity. So fun facts, cubics are going to have opposite answers to end behavior because they are pointing opposite ways. All right. I know you guys missed end behavior so much. Let's talk about if we make the leading coefficient negative. So I know a negative is going to reflect it over the x-axis, and so I'm going to have a quadratic that opens down. Let's review that end behavior. Let's go ahead and stick with the positive infinity first. So as x goes to positive infinity, which means on the right side, what is my arrow doing? My arrow is going down, which would be negative infinity. My left arrow would be as x goes to negative infinity. It is also pointing down, so your f of x or your y value would be negative infinity. So it's a nice little review from before fall break. Now, if you put a negative in front of a cubic, it's going to reflect over the x-axis and go down. So our snake will now snake down. And let's talk about the end behavior. I'm going to always start it off like this. Check the positive infinity, check the negative infinity. And I'm going to actually give you guys some time to try this. Press pause. See if you can tell me the answer to this end behavior. Press pause now. So, as x goes to positive infinity, which would be the right side, my right arrow is pointing down, so it is negative. As x goes to negative infinity, that means the left.